Welcome everyone. In this video lecture, we will solve a GATE 24 EC question in which we have to find the small signal voltage gain, that is our magnitude V out by V in calculation we have to do for a multiple MOSFET problem. So in a multiple MOSFET, so means here the circuit is this. So the question is in the circuit shown below. So there is a circuit, okay, in which there are two transistors M1 and M2 are there, and both are operated in the saturation region. Okay, so both are operated in the saturation region. In addition to that, biased in the saturation, the small signal transconductance, the small signal transconductance are gm1 gm2, and we have to neglect the body effect, channel length modulation, and intrinsic device capacitance. So we have to know worry about the body effect, channel length modulation, and intrinsic device capacitance. So for a small signal model, we have to eliminate, or we have to short circuit the AC capacitor in the short circuit a small signal analysis. So it is already written. So we have to find the value of V output by V in. So options are given, option A, B, C, D. So we have to encounter this question. So this question is easy, but we have to know some concept behind the small signal model. So here I have already draw the same diagram here. So in our question we have to find the value of here I am writing V output by V in magnitude. Okay, that we have to find. So what we can observe that this M1 transistor is nothing but simply a diode connected configuration, we can say, configuration in a MOSFET. So this diode configuration exhibits a resistance that is our 1 by GM1. If we know this concept, we can easily solve this problem. So now for this purpose, I am just showing how this first diode connected device MOSFET, when the gate and drain, this the drain of one and gate of transistor 1 is sorted. So this one is a diode connected device, and it will exhibit 1 by GM resistance when we will look from this side. Okay, so what I am doing, I am just making the circuit for, because this one is important. If we directly solve, then one can ask how we are writing this. So this one is our gate and drain. So this gate and drain are sorted. Okay. So if we draw the equivalent, a small signal equivalent model, so what we can say, here the gate and drain are sorted. So what we are doing, gate and drain are sorted. Okay. This one is our GM VGS. Okay. Plus of minus VGS, and then after we can add R naught, or we can remove R naught. Here I am, okay, here I am removing R naught because we have to neglect the body effect. So we have just putting a test voltage Vx and Ix. So the resistance looking from this side we can find. The resistance looking from this output side can be easily find. So now this is nothing but simply this Vx. So we can write the voltage X across this. Okay, one more thing I am writing. This was a gate in, drain in, and the source. This was our source in. Okay, so from here, what one can write, this Vx is same as that of VGS, Vx and VGS is same potential, and Ix equals to GMVGS. If R naught will be there, simply 1 by GM1 parallel with R naught will come. So that I will write later. So now the value of VGS by Ix is the output resistance value. It is our 1 by GM. So if this one is transistor M1, so we can write as GM1, GM1, GM1. Okay. So this one is the resistance looking from the this side. Okay, jet node. So this one is nothing but simply a resistance. We have to make it ground, or we have to just make it ground and open circuit. This one, so if we take this as a transistor, okay, diode connected, so this is nothing but simply 1 by gm. So there, now it is very simple. This rb is in series with 1 by gm1. So the circuit can be remodified as the circuit here I am writing. I am just doing here. The circuit is somehow remodified as at 1 by gm1. Okay, so the circuit is modified by gm1. Instead of this, okay, we have just replaced with the one resistance 1 by gm1. So now we can easily solve this problem by using a small signal model. Okay, so now we have to draw the small signal model for this circuit. So what we have to do first, we have to make this one. Okay, this one is a source of 2. Okay, s of 2 I am writing, and this should be v output, or here. Okay, this one, this current source should be our gm2 vgs2. Okay, and in addition to that, this one is our VGS2 for this one, and one RD is there, and this should be grounded. We are doing the a small signal analysis, so we have to make it ground. So the RD resistance will come here. Okay, so make it like this RD, and this one is the drain to get to terminal. Now from get to terminal, this one is our get to drain source to terminal. Now from this gate side, one RB is there, and one by GM1 is there, and directly we have to add RS, and we have to make it capacitor will be sorted in the small signal analysis. So this one is nothing but simply V in. Okay, so the thing is that first we have made the small signal model. Okay, we are not putting the R naught because it is already cleared, that no need to take care of the body effect, channel length modulation, and device capacitances. Okay, so this one is the thing, and RD, this RD we have put it here with ground for the DC ground, and 1 by GM1, and RB is in like this, and this one is a VS. Okay, and we are giving the V in, you have to find. Okay, this one is RB. So this one is the overall circuit. Now again, what I am doing, or we can directly write from this figure that V output is nothing but simply GM2 VGS2 RD with minus sign. This one is a plus minus, and current is flowing somehow like this. Okay, so here we can say the V output equals to minus this current into resistance GM2 VGS2 into RD, because the current is going from the negative terminal, so this should be minus GM2. Simple, this one is the circuit, so it should be okay, V output minus GM2 VGS2 into RD from this side. Okay, V output. Now we have to calculate the value of VGS2. Okay, so this VGS2 we have to calculate. So what I am doing for this VGS2, V in, this one is RS, and this should be can be written as RB plus 1 by GM1, and this voltage is our VGS2. Okay, the same thing this side, the this side I have make the this circuit for the this voltage is our overall VGS2. Okay, overall VGS2. So here, so now through voltage division rule, directly one can write the VGS2 equals to this source resistance, source signal V in into RB plus 1 by GM1. Okay, V in into this divided by the overall resistance RB plus 1 by GM1 plus RS. Simple, I am just giving the formula here. If R1, R2 is there, if this one is V1 and this one is V output, so V output equals to V1 into R2 by R1 plus R2. The same concept we have used here. Okay, simple uh, Kirchhoff's law we have to apply or something, then we can easily find the value of VGS2 like this. Okay, so now VGS2 in as a function of V in, so we can directly put the value of VGS2 in the equation, this equation. Okay, so what we can do, okay, I have to select pencil. So one can write V output equals to minus GM2, okay, RD here, and VGS2 is nothing but simply V in into RB plus 1 by GM1 whole divided by RB plus 1 by GM1 plus RS. Okay, so one more line we can write V out by V in equals to minus GM2, putting this in the left hand side, GM2 RD into RB plus 1 by GM1 RB plus 1 by GM1 plus RS. So this one is the gain. Okay, this one is the gain. Okay, this one is the gain. So in the question they are asking about the magnitude. Okay, so we have to write V output by V in, we have to find the magnitude, so it should be negative sign will be removed, and simply we have to write GM2 RD RB plus 1 by GM1 whole divided by RB plus 1 by GM1 plus RS. So this one is the final result that we are looking for. Okay, so the overall gain will be GM2 RD into RB plus 1 by GM1 by RB plus 1 by GM. Sorry, so we have to check which one is the correct answer. GM2 RD, GM2 RD into RB plus 1 by GM1. Okay, so I think option number B, GM2 RD RB plus 1 by GM1. Okay, so the option B is the correct one for this question. So this one is simple one, but we have to little bit careful about the concept of some standard function like this diode connected device. So it should be 1 by GM1, so which can be easily derived. So if R naught we have to take, so if R naught, so the overall resistance will be R naught parallel with 1 by GM. Okay, but we have to neglect this thing of R naught, so that's why we are directly doing like this. Okay, so the thing is that we have to know the very simple concept about the small signal analysis, so we can encounter such question. So thank you for watching this video.